Hi friends, in this very lesson, you're going to be solving the first question we're given as a take home in our previous lesson on circular motion under physics. In our previous lesson, we perfected everything on circular motion and we're given 5 major questions to get us tested. So if you want to check if you could, really attend this very question, I'll give you some time to do that right away. Okay guys, let's see how many people got this very question right. A string wound on a rim of wheel 20 centimeter in diameter is pulled at the rate of 75 centimeter per second. Through how many revolutions will the wheel have turned by the time 9 meter of string has been unwound? How long will it take? Now we have 2 major questions under the very first question. So this very question is a typical circular motion question. And it's very simple. All we just need is, we just need our major formulas. Don't forget, if you've not seen the previous lessons, you may find it quite challenging to solve this very question. So you need to go and see the previous lessons and the formulas for you to understand how to solve this. So first of all, let's understand what they're trying to tell us. We have a rim right here. I may not be able to draw something perfect. Let's say we have a rim right here like this. And this very rim, we have a kind of a thread being wound around it. So we have a rim, the radius of this rim, the diameter, I beg your pardon, is 20 centimeter. That's the diameter. The diameter of this rim is 20 centimeter. So the knowledge of math matters. If the diameter is 20 centimeter, because you're talking about a circle here, it means the radius is 20 divided by 2, which is 10 centimeter. That's very simple. And don't forget, the next thing we have is being pulled at the rate of 75 centimeter per second. Now, this very quantity given to us, this is a linear or tangential speed. That's what we have here, this distance over time taken. So we have a linear or tangential speed. So we have that v is 75 centimeter per second. So this linear or tangential speed. So look at through how many revolutions will the wheel have turned by the time 9 meter of string has been unwound. As you can see that this meter per second, this should be meter per second because we have a major system known as, you have a CGS system, you have the MKS system. So whichever one, the centimeter, gram, and second, meter, gram, and second. So for the fact that we have centimeter per second, let's see, we may end up converting, let's just convert it directly. Let's move this to meter per second. 100 centimeter make 1 meter. So that will be 75 per second divided centimeter per second divided by 100. That'll give us 0.75 meter per second. So we have our linear or tangential speed already in 0.75 meter per second. So through how many revolutions will the wheel have turned by the time 9 meter string has been unwound? Now, the revolutions we're talking about, don't forget that when we talk about revolutions, we're talking about angular distance. We talked about that already in our previous lesson. So don't forget that for circular motion, we have everything angular and everything linear. So here we have to get the angular distance. That's revolutions we're talking about. So through how many revolutions will the wheel have turned by the time 9 meter string has been unwound? Now we can use various formulas. Now since it's 9 meter string, don't forget after one revolution, some meter or some centimeter of the very string, would have been unwound. After another revolution, so we're talking about one revolution is simply a full cycle through this very circle. That's all. That's what one revolution is. So if 9 meter of string was unwound, or is being unwound, I mean, so how many revolutions would that be? Don't forget that after one revolution, that's one full cycle, cycle through this, some meters of string, will be unwound. So by the time we have 9 meters of string, so how many revolutions would have been made? How many turnings? That's angular distance. That's what we're talking about. So we have a major formula we could use. We could use our linear distance equals to radius times angular distance. So angular distance could be in revolutions, although the standard unit for angular distance is radians. So angular distance could be in radians, could be in revolution, and also could be in degrees. It depends. All this has been discussed in the previous lesson. So we're going to use this, and after using it, we can use the analytical method also. So don't forget the total distance is 9 meters. That's what we're talking about. Distance 9 meters. So the radius, what was the radius? The radius is 20 centimeters. So we're going to move that to meters. Divide that by 100, that will give us 0.20 meters. That's what we have. We have the radius already converted. So we're looking for this. This is what we're looking for. We're going to get this. When we get this, we're going to get this in radians so we can move it to revolutions once we're done with that. So this 9 meters, because the radius is 0.20 meters times the angular distance, that should be in revolutions once we're done. So if the Bible start by 0.20 meters, then 0.20 meters. So the angular distance is 9 divided by 0.20, which will give us 45 rad, 45 radians. So we're going to move this 45 radians directly to revolutions. So we'll do that. So 45 radians to revolution, don't forget 1 revolution is 360 degrees, which is 2 pi radians. So if 1 revolution is 2 pi radians, then 45 radians will give us what? What would that give to us? How many revolutions would that be? Just cross multiply. So we have 2 pi x rad, which is 45, which is 2 pi x revolution. That's what we're talking about. 2 pi x equals to 45. So we divide both sides by 2 pi. So what do we have? 45 divided by 2 pi. Let's use our calculator to solve that. 45 divided by 2 pi will give us 7.16. That's about 7 revolutions. That's what we have. That was the right answer. So right here we have 7 revolutions. So this very whole setup makes 7 revolutions for 9 meter to be unwound. So this is one of the major methods we could use. We could use other method. We could use another method. I will show you quickly the analytical method for this. So let's see how we could use our analytical method. So this is what we're going to do. We take out a portion of this. Let's take out a portion of this and use another approach. So when we use this, we're still going to get the same 7 revolutions. You're still going to get the same thing. Now don't forget, this is what we're going to do. Now in one revolution is 2 pi r. Don't forget, revolution is simply the circumference of a circle, the total distance around it. So if one revolution is 2 pi r, it means one revolution is 2 times pi times radius. What's the radius? The radius is 20 centimeters. In meters is 0.20 meters. So that 2 pi is 0.20 meters. So one revolution, quickly, that will give us 2 pi is 0.20 meters. So let's see what that would be. So that would 2 pi times 0.2. That's that will give us about 1.256. That's 1.26 meters. That's what we have. So one revolution is 1.26 meters. Now that means each time we complete unwounding, that's through one circle like this, as about 1.26 meter is the amount of string that is being unwound. So now, how many revolutions will it take for 9 meter string to be unwound? So let's see that. It's quite very direct. So S revolutions, just cross multiply. So 9 times 1 is 9. So 1.26 x divided by 1.26. So we end up having 9 divided by 1.26, and that will give us 7.14, about 7 revolutions. Still the same result. As simple as ABC. So this is just it. So either you use the first method or you use this method. So this method is very direct. So whichever one is okay. So the next thing we're going to solve now, we're going to get how long it takes the whole, the whole circular motion to take place. So we've gotten our revolutions already. So let's see how long it takes this, to take place. Quickly, that's what we're going to do. So we're going to see how long it takes this to take place. So we could use 2 methods here for us to get the time for this whole revolution. Now we could use the the angular formula method, or we could use the linear formula method. Now don't forget, we have our distance already. If we use the linear or the tangential, we have our distance to the 9 meters. Distance is 9 meters. So we have the velocity. Velocity is already stated 0.75 meter. So if the velocity is 0.75 meter per second, and we have the distance to that distance traveled, so how long will it take it? That's the time. So don't forget, simple formula, velocity is distance or displacement over time taken. So if we have this, is 0.75 meter per second equal to the distance, which is 9 meters over time. So for us to get the time, we cross multiply, this comes down here. So it means the time would be 9 meters divided by 9 divided by 0.75. That'll give us 12 seconds approximately. That's absolutely 12 seconds. So that means it takes 12 seconds, or it took 12 seconds for this, for 9 meter string to be, to be unwound. As simple as that. So if you don't want to use this, you can also use something else. You can use something else. How to use this? To do it another way around. So to use this, you could do something different. So let's see what else you could do. Now, don't forget, we are looking for how long it takes. So we could use this formula. The angular velocity is equals to angular displacement over time taken. The angular velocity is angular displacement over time taken. So if this is what we have, that means we're going to get first the angular velocity. The angular displacement is the angular displacement was gotten. We got that. We already got that ready. So you're going to get the angular velocity. So don't forget the linear velocity is a formula. Linear velocity is equals to angular velocity times radius. So the linear velocity is 75 centimeter per second. The angular velocity is what we are looking for. The radius is 20 centimeter, as stated. So divide both sides by 20 centimeter by 20 centimeter. So what do we have? The angular velocity is 75 over 20. That will give us 75 divided by 20. That will give us 3.75. Now, angular velocity naturally is in rad per second. It's in rad per second. So if our angular velocity is 3.75 rad per second, so what is our, our angular displacement? We got our angular displacement. We got our angular displacement already. So let's see. It's taken off already. So let's quickly get it back. So this is a linear distance. This is what we have. So don't forget, we have a string wound on a 20 centimeter radius is pulled at the rate of 75 centimeter per second through how many revolutions will the wheel make 9 meter distance. So if what we have is 9 meters, and we have the radius to be 0.2 meters, 20 meters. So the angular over this, we just do this. We do this 0.20. So what do we have? We end up having 45 rad. That's what we have approximately, 45 radians. So we have everything set out. We have the angular, velocity to be 3.75. Then we have the angular displacement to be 45 over time. We cross multiply, so the time will be 45 over 3.75. Quickly, let's divide that. 45 divided by 3.75. That will give us 12 seconds also. As easy as that. So various ways you can attempt this very question. So as you can see, it's very easy and direct. Time 12 seconds, about 7 revolutions. So that's that for this very class. So we're done with the solution of the very first question we are given as a take-home in our previous lesson. So if you have gained something or gotten something, and I would love you to give me a follow at Revolution Hub on Facebook, and also please subscribe to this very channel at EduMosaic. And please share the lesson also with others. See you in the next lesson. Thanks.